I suspect that you might already be familiar with the term mixture. It really does mean what you think it means. If you take two or more substances and you were to mix them together, you are dealing with a mixture. And it could be a solid, a liquid, or a gas. Now, there's fundamentally two different types of mixtures. There's heterogeneous mixtures. And hetero, you're going to see that prefix a lot, means different. So heterogeneous. This is referring to mixtures that if you look at it from a macro point of view, I'll do a heterogeneous liquid mixture. And what I often think of here at the extreme form is where with my naked eye I could see that different parts of the mixtures have different concentrations of the different things that have been mixed up. One example I often think of is chocolate milk that's not well mixed. At the top, you're going to see these clumps, and depending where you are in the milk, you can actually see it with your eye, that you don't have consistent concentrations of the different substances. The properties of the mixtures are different depending on what part of the mixture you look at. Now, you can imagine if there's heterogeneous mixtures, the opposite would be homogeneous mixtures. Those would be mixtures that when you look at it from a macro point of view, it looks consistent. Any point of the mixture. Homogeneous mixtures. And homogeneous mixtures, there's another term for it, which you have probably heard. They're also known as solutions. And as I mentioned, when we talk about mixtures, we could be talking about solid, liquid, or gas. Oftentimes in our head, we think liquid immediately, but it could be solid, liquid, or gas. And so the same thing is true for solutions. You could have solid, liquids, or gases. And an example of a solid solution would be, say, a metal alloy, where at the macro level, its color, how well does it conduct electricity, how malleable is it, how hard is it, it looks like the properties are uniform throughout the alloy. If I have some type of metal alloy, if I were to just look at it like this, if I were to look at, say, bronze, well, from my point of view, it has the same properties throughout the bronze. I should probably do bronze in a more bronze color right over here. But if you were to look at it with a very sensitive microscope, or based on the models that we now know what is going on in that metal, in that alloy, what's happening is you actually have a mixture of metals. But it is a homogeneous mixture of metals because at a macro level, you can't really see the differences. Now, at a micro level, you can, because there are different metals mixed in together in this alloy. Now, as you can imagine, you also have liquid solutions. And in chemistry, these are the ones that we'll often deal most with. We'll also deal with solid and gas solutions as well. And when I think of a homogeneous liquid mixture or a liquid solution, the one that comes to mind for me, but we'll see a lot of these in our journey through chemistry, is salt water. Salt water. Salt water has sodium chloride dissolved in water. And if you were to go to the ocean, and if you were to just look at the salt water, or if you were to measure its properties, even in a lab, you would see that the properties throughout the salt water seem to be uniform. At a macro level, it appears to be homogeneous. It appears to be uniform. But if you were to look at what's happening at an atomic level, you would see that you have your water molecules. Let me draw the water like that. That is the oxygen. Each of them has two hydrogens, and this end is partially positive. We've seen this multiple times. The hydrogen end, the oxygen end is partially negative. And so when you dissolve the sodium chloride, the chloride anions are attracted to the positive ends of the water. So maybe you have a chloride anion there, and the sodium ions would be attracted to the negative ends of the H2O. So that's the sodium right over there. So when you look at it at a micro perspective, you see that there are different molecules. But at a macro perspective, the macro properties, how it responds to different stimulus, how well it conducts electricity, what it even looks like, it seems to be uniform. Now, to be clear, salt water is not the only liquid solution. There's many types of liquid solutions. In chemistry, we'll often see water as our most common solvent. That's the thing that you have the most of, the thing that other things are getting dissolved in it. The things that are getting dissolved are called the solute. In this case, it would be the sodium chloride, and the water is the solvent. Let me write that down. Solvent. And when you have a solution where you have something dissolved in water, this is often called an aqueous solution. And sometimes it's abbreviated AQ. Now, last but not least, we haven't talked about gases yet. And you can, for sure, have a solution of gas. And the one that's most common is the one that you and I are breathing right now. The air around you is a gas solution. Its macroscopic properties seem consistent. They seem uniform. But we know that the gas around us is a mixture of nitrogen, of oxygen, of carbon dioxide, as well as molecules of other things. So a good example of a gas solution would be air. So I'll let you go there. That's just a good primer on what a mixture is, the types of mixtures, and especially the subtype of a mixture, which is a homogeneous mixture, which we often call a solution.